Hi, hello everyone. Thank you for joining us today. I'm today's speaker, Jacob. I'm the BI solution consultant of FanRuan. Today we are going to talk about def function. So first of all, I would like to pose a question here. Have you ever encountered any of these following problems in your BI analytics dashboard development? Like, have you ever encountered the need of some data across rows? Are there times when you need to perform complex grouping calculations on data and you don't know how to set up the grouping? Or you know how to set up the grouping, but it was a lot of steps and got tired of creating multiple calculated fields to step through the calculations. From time to time, we have been approached by a customer who wants to do complex calculations, but the fixed function is only available in direct mode for version 5. Or the quick calculate function. All the calculation results are dynamic, and the results for example, year-on-year calculation will be lost after you filter in the data in detail filter. To address these needs, we introduce you the def function. Def function can create a static indicator with grouping and filter calculation. It allows user to perform dimension-based calculations in self-service datasets and interline calculation with def and earlier function. The def function system contains a series of functions. It includes def function for create static indicators and def add, def sub function for creating dynamic indicators. There is also the earlier function for getting the value of current computed row, so you can do cross-line calculations. In today's session, we will go over each function and the calculations behind them. So for LOD calculation with def function family, you can use def function to perform dimension-based calculations in self-service datasets and use earlier function to perform interline calculation. Now we will first do a quick introduction to def function itself. And actually, all the other functions are based on this def function. So def function will aggregate indicators according to the dimension with aggregate function. And for the detailed data that meets all the filter conditions. Def function contains 3 parameters. So for the first parameter, it's the indicator. It is the indicator you want to use for your LOD calculation. It must provide and it must be wrapped in an aggregate function. So it can support all aggregate functions provided in FineBI, such as sum aggregation, count aggregation, and etc. For the dimensions are the dimension you applied in your LOD calculation. It is optional and you can provide multiple values to group data with multiple group elements. And you can input them and separated by comma. For filter conditions, they are conditions you use for your calculation. Only values under true condition will be taken into calculation. It is optional and it also supports multiple value input. Now we will go through a very quick example to tell you how that function can be used. So now we have to use a dummy data set. So the dummy data contains group, subgroup, value, and is valid column. In this example, we are going to get the sum of valid values for each subgroup. And to reach this target, we have to first group the data by group, next by subgroup, and then pick out all the data with is valid equal to true and run sum on them. So for the first step, we are going to add a formula field. And the formula to be used, I already put it here. It's def sum aggregation value with group, subgroup, and is valid equals to true. So nextly, I will introduce you how the background calculation is performed and what each parameter do in this calculation. As you can see, for the first step, all the data are grouped by the group group parameters you provided. You can see for group, it's grouped as alpha and beta. And for subgroup, we had two groups named A and B, and they are all under their major group. And for the next step, we are going to test is valid equals 2 on each individual line. You can see for the first line, is valid value is false, and it didn't meet our requirement, which is valid must equal to true. So we put a little red mark here to show you that it doesn't meet our requirement for the summary. And we go through all the calculation until the last line, and you can see the results. Nextly, we will run the sum aggregation function on our valid line. You can see all the value is true in its valid column is taken into the summary. And for group beta, subgroup B, there is no true value. So you can see the result is empty here. And absolutely, when you do calculations in data preparation, you will not see this group table. So for FineBI, it will copy all the values to the result line and show you the final result in a detailed table format. And you can see all the values here. And for the last two lines, because the calculate value is empty, so for the cell itself, it's still empty. Nextly, because for def function itself, it only creates static indicators. For example, when you use them, you only limit it to the dimensions you provided in your calculation on your dimension parameter. But sometimes you want to dynamically change your dimension when you create dashboard. So we also provide def add and def sub function. For def add, it means it will group by the dimensions placed in the component, plus the dimensions you provided in your function parameter. And for def sub function, it means it will group by the dimensions placed in the component when you design your dashboard, minus the dimensions you provided in the function parameter, which I will demonstrate you how it is used in our live demo later. And to be noticed, because def add and def sub includes the dimension you have to place in the component, so they are only allowed to be used when you design your component, not during the step of data preparation in your self-service dataset. And nextly, we have our earlier function. So it may be a bit difficult than def function to be understood, but actually earlier provides you with the functionality to do cross-line calculations. For each calculation, you have two concepts. One is the current row and one is the group data. For example, here we are going to use this dummy data set with group, subgroup, and value. For group, like we still have two groups, and subgroup still A and B group. For this case, we are going to calculate two targets. So the first one, we are going to get the ranking of values. Next one, we will go a step further. We are going to get the in-group ranking of values by subgroup. For the first step, you still need to add a formula field, and the formula will be like this. For the first step, we are still grouping data based on the group parameter we provided, which is group, subgroup, and value. Different from last case, because this time we are going to get the ranking. So ranking is not for the group, it's for the value itself. So in the grouping parameter, we need to put value here so we can get the very finest detail. And you can see I draw a graphic on the right, which is a whole column of value. For earlier in your if you use earlier in your calculation, it will create a subview for each individual cell of your aggregation. And the expanded view is a whole column of your current calculated column. Like over here, we are going to calculate value with count aggregation function. So in this case, for value line, for the very first cell, it will expand the whole column, like from the first column of first row to the last row, sorry, from the first row to the last row. And then earlier function actually gets the value of the current calculated row, which is the very first cell. Nextly, we will go through all the steps to test if the individual cell needs to be taken into calculation. For example, for the cell 1, its earlier value is 1. And it will be compared with all the current values, all the cell values of the expanded view. For example, is 1 larger than 1, it's false. And then if 5 larger than 1, it's true. 2 larger than 1 is true, and it will go to the very end. And then it will run the count aggregation function on this expanded view. So for this case, the count aggregation gets the number of 7. And when we doing ranking, you have to add 1 on the current value count. So because we have 8 values here, and 1 is the smallest, and we can get its rank is 8. And we will go run this calculation for each individual cell of the original table until the very last cell. And you can see the result here. It's ranked from the biggest to the smallest. And still for the last step, it will, sorry. And for the earlier function, it creates a subview under the specific dimension grouping. And when you see it in your self-service data set, it will be shown as a detailed table format, not this group table format. And the next case is to get the in-group ranking for the whole table. So we want to get the value, the rank of the value in each individual subgroup. So you can see here, we added 2 more conditions in the formula. It means when we created this expanded view, you can see it will only expand with values that reaches these conditions. These 2 equal conditions. You can see for group alpha, subgroup B, cell 1. For this cell, values with the same group and the same subgroup is only 1, 5, 2. So it expands with 1, 5, 2, this subview. And then still, we will run all the calculation, like if the value is larger than this cell value, is, for example, if 1 larger than 1, it's false, 5 larger than 1 is false, and 2 larger than 1 is, sorry, 5 larger than 1 is true, and 2 larger than 1 is also true. So when we run through this count aggregation and +1, we can get its final ranking. Like for the value 1 in 1, 5, 2, it's the smallest. And for the second value, 5, it's the biggest, and so on. You can see it goes through all the calculations here, and you can get the table of final results. Nextly, I want to show you a few real cases. I will first demonstrate you in the real environment for the last 2 cases, and then we will do all from scratch for another two real cases. One is cohort analysis and one is sales conversion rate analysis. So nextly, we'll go to the real environment, and we can pause for a moment. If anyone have questions, you can ask us in the chat and I will answer them. Okay, I see one question. Like in our tests, ranking with depth is very slow on large data. Yes, that is possible. And our development team is working very hard to improve the performance. And as you can see, it actually on the very background, it needs to create a subview for each individual cell. So the total data set it needs to be calculated is larger than your original data set. So it can be a bit slow, but our algorithm team is working very hard to solve this issue to improve the performance. What is large data in gigabytes or rows? For FineBI itself, yes, 40 million rows is a very big data set. So our recommendation is first you can do some grouping to reduce the overall row number of your data. Like you can first run the group, run some grouping to reduce the total amount of data, and then apply the depth calculation. Okay. Yes. Is it possible to use depth functions with dimensions from different table? Yes, absolutely. But you have to create relationships between different tables. Like you have to create like join or like join relationships between different tables. Then you can create calculation with depth function. Okay, we will wait like 1 more minute if anyone have any more questions. And if not, we are going to the next stage and I will demonstrate to you in the real environment. Okay, now I will run a few live demos in my test environment and show you how that function is used in this case. For the first case, we will use that function in our data preparation step. For the first step, we are going to add a formula column, which we can name it group summary. So we are going to calculate the group summary. So this is a very most simple use case for that function. And actually, it can also be done with other functionalities in FineBI, such as quick calculation or like group summary function. But today, since it's like demo for that function, we will only use depth. To perform this calculation, we'll first enter depth and we are going to sum. So we use sum aggregation and sum the value. Sorry, we are going to sum value. And for the grouping conditions, we are going to put group itself and without the last parameter. And we are going to preview the result. And you can see here is our group summary. And for example, if we want to sum values only larger than 40, larger than 50, like 50, 60, 70, 80, which is these four values, we can edit this calculation and add the condition for the future condition, which is value larger than 50, larger or equal than 50. Okay, and we preview again. You can see this time we still get all the results, but you can see the result value is changed. For the first group, like if I rank by group, it will be easier to recognize. So I will add a, sorry, ranking. Okay, no, I won't rank it. You can see for the first group, it contains the ID 1, 2, 3, and 8. So because only 80 is larger than 50, you can see the result is only like 80. But since all data are in the same group A, so the result will be copied to each individual cells. And you can see for the second group, like 50, 60, 70, it's like 180, and 40 is not taken into the calculation. Oh, sorry. I made a mistake. You can see now, right? Okay, I will start from beginning. Sorry for my mistake. Okay, you can see here's our data set, and we are going to do the very simplest, the most simplest calculation, which is get the group summary. And I will name the field group summary. And for this calculation, first we enter def, and then we use, because we are calculates the summary, so we use sum aggregate and enter value as our aggregate target. And for the grouping field, we use group in this case and press OK for the result. Yeah, and as you can see here, we get all the results for group A and group B. And in some cases, we want to like do filter together with such calculation. So in this case, for example, if we have to filter out data with value equal or larger than 50, like all these 4 lines with ID from 5 to 8, so we can edit our calculation to add our filter condition with value larger or equal than 50 and press OK. And now when we preview it, you can see the value is changed. And for group A, because only the last value is larger than 50, so all items in group A is with group summary value only 80. And for group B, you can see there are 3 values larger than 50, so we get the final result, which is 180. And sometimes we have multiple groups, and we have to group by multiple dimensions in our calculation. So in this case, I will show you like how we can calculate by like 2 dimensions. Still, we add a calculate formula, And still like groups, we will do group summary. And in this case, we will first group by group and then group by subgroup. So still add def and sum aggregate value. And now, because we have to add multiple dimensions, we have to enter it like this. First group, secondly subgroup. And for future conditions, we still put in nothing. And we can preview it. And you can see the calculation is first grouped by the major group, which is A, B, and then grouped by the subgroup like A1, A2. And for example, if we want to get the result only for like group equal to A1, we can also add the calculation over here, like subgroup equal to A1. Anyway, it didn't. Oh, sorry, my mistake. We can't do this. For example, we are going to still filter with value larger than 50, larger or equal than 50. Okay, and we preview it. You can see this time some of the values didn't show because you can see for A2 group, there is no value larger than 50. So for A2 group, the group summary is empty. And same case is for B1 group. For B1, only there is only one value in B1 group, and none of the value is larger or equal than 50. You can see it's also go empty. And nextly, we want to calculate the ranking for the value. Now we add another calculate column. We enter rank for the name. And for calculate ranking, we can go rank by other direction. So first we still enter def. And because we are calculate ranking, we will use count aggregation instead of sum aggregation in this case. And for ranking calculation, you can use any field as your to count, but not with the group field. Okay. So for example, I will use the ID field for counting, and for grouping conditions, first we will group by the big group, and then we'll group by subgroup. And lastly, because we are calculating the ranking for each individual value, so we will also add ID here as our conditions. And because calculate ranking is a cross-line calculation, you are comparing values from different lines. So you have to use earlier function. And in this case, we can use value larger than earlier value. And we can preview the result. And you can see all the value is ranked from, you see, I didn't put the +1 here. So you can see for the first value, it only ranks 7. And for the last value, its rank is 0, which is incorrect. Because for the last value, when it is counting the values that's smaller than itself, it gets only 0 the result. Absolutely. So we have to edit our calculation with count aggregation ID and +1. as our final result and preview it. Now you can see we get the correct ranking from 1 to 8. So this is a very basic use case for our demo. And nextly, I will go to a case of a bit with a bit more like complexity. I will back to my demo and we go to case study. So I prepared 2 cases. For the first case, sorry, a bit time to load. Okay, for the first case, I get a retail data set, which is some data of retail. And you can see there are a lot of fields. And today for demo, we are going to calculate like, for example, if a client has first purchased the product in, for example, 2020, and another client is first purchased the product in 2013. So we want to know, like, for the client of, we want to group clients by their first purchase, and we want to see different clients from different year and go to the future, like how many revenue they added to the host to the total. I will show you my PowerPoint show over here. So we are going to group data based on where customer. Sorry, I will share my screen again. Okay, so our target is to group data based on when a customer makes their first purchase and to understand the contribution of each customer to sales. For example, we will get customer from 2020 because our dataset starts from 2020. All the data it only gets one bar, one section. And when we go to 2013, you can see the client which they first purchased last year is shrinked in the total sales, but we added some new clients in this year and one by one to the last. And for this case, we'll create a new component. And this time we will do the calculation in our component. And for this case, first, we will create a calculated field called the first purchase date. And you can see I already put the calculation here. So because we want to get the first year of client purchase, so we will go to, we will use minimal aggregate for order date, which we can get the earliest year they purchase the product. And we will group by customer ID because we want to get the date, the value of each individual customer. And with this set, we can start creating our graphic. For example, we put order date into dimension, and we put sales in our indicator. And we change the chart type to stat column chart. And we will change the date format to year only. And you can see here's the revenue of all 4 years. Then we are going to separate them by their first purchase date. So we put first purchase date into color. So we will color them. Also, we have to change its format to year. And you can see here we separated into different years for their first purchase. And to be understand more easily, we will label them with first purchase date. Also change to, sorry, also we need to change to year. And you can see here's revenue of 2012, and all the clients are from the same year. And for the revenue of 2030, there's revenue from customer first purchase in 2020 and 2013, and so on. So let's pause a little bit here, and maybe if anyone have questions, you can raise it now. Yes. Sure, please ask. Okay, sure. We'll add a dashboard and put our components in. And add a year filter. Mm-hmm. Mm-hmm. Just a second, let me check, because by design it should not it should not work like this. Sorry, just a second. Okay, I think we have a bit of issue here. Yes, actually in the previous version, that function always operates before all the filter components, and actually we can get the value of correct grouping. But I just updated to the latest version today, and I'm not fully aware what this happens. I will check with our dev team later, okay, and give you a feedback on this particular issue, because that function, it is aimed to solve the issue that the context of future components will affect the value. And actually, if we created this calculate field in our self-service data set, it can be bypassed for this issue. Like if you create the result, create the def function in your self-service data set, all the result will be fixed in the data set, and it won't be affected by filter, which we can test here. And I won't use. Okay, I will add a column here, and I will save and update this data set and go to the component. Instead of this column, I will use this column. Okay, I will color it and label it. And now if I go to the dashboard, you can see it's correctly filtered. For a second, I put a detail filter here. I'll remove. Okay. And you can see for my dashboard, it is filtered correctly now. I think this is what you require, right? You have to like use that function in self-service data in your data preparation stage. Then you can bypass the filter components. Otherwise, when you use it in your dashboard, it's still dynamic. But different from our previous function, like a lot of operations is only allowed to be due in dashboard design only. For example, if you want to calculate for example, the quick calculation year on year, month to month, and so on. Yes, absolutely. I will record your requirement and pass it to our development team. Sure. I think it is very reasonable requirements that you want to, like, for example, enter some parameters into your dashboard and get the real-time calculation, right? Okay, I think we can go to the next example. So how to use earlier in your calculation. For the second case, we will get this funnel charts to show like for each individual step, like when you, this is a car selling data set. So it is like, it is the data of each individual steps of the car selling. For example, for your key stages, you get leads from your advertising. And when customer sees your advertisement, he will go to the store. So we also get like leads from your shop. And next step, maybe clients will take a trial run and salespeople will provide a quotation, and the client will place order and get the final delivery. Okay, so we are calculating like the conversion rates between each steps. For example, convert from advertising leads to shop leads, and the ratio of converting from trial run from shop lead to a trial run and to the next step. Okay. And we will go to a empty component. For the first step, we will still create a calculated field, and we will name it as client count for each node. And for this calculation, we want to first get the sum of the clients for each individual like sales step. So we will enter def sum aggregate and client count. So I will use the existing one. So it's some aggregation client counts on each individual key stage with a def function. So this is our first calculation. And nextly, because it's always like the previous step have more clients and the next step has less clients. So we will get a rank for the key stages. So for example, we will like first count aggregate the key stage +1. So this is getting the rating. We will rank each step from the first to the last. So when we're creating our funnel chart, all the data can show in the right order. And then we will need to get the client count of the previous stage. For example, for the second stage, like how many clients, you have to get a column of how many clients in the previous stage. And I will show you in a detailed table how all data looks like. First key stage and the client count of current stage. And the client count of previous stage. And we will order by conversion rate. Order by key stage ranked. Anyway. And you can see here, lead from advertising, it's this number, and lead from shop. So for the current stage, and also the data from the previous stage. So this is actually count of lead from advertising. And also one by one. And then we can use this data set to create our funnel chart. I will switch the chart type to funnel chart. And you can see it is not in the correct order. So I will change key stage and order it with ascending order by key stage and by client count. And then maybe we can put it with color for different stages. And we can label them with the conversion rate. And you can see we can add this conversion rate calculation by like directly divide some summary of current stage and the previous stage. And now I will label it with our conversion rate. And because it's not shown in the percentage format, so I will change its value from format to percentage and click OK. So you can see the conversion rate for each different stages. Okay, that's all for today's session. So we still got a last few minutes. So maybe you have any questions, you can also raise them in the chat. And the video recording for today will publish it later, and you can always see it and review it. And thank you all for supporting us, and thank you for joining us today. And please looking forward for our next online course. Sure, please. Yeah, sure. Thank you. Have a nice day. And if you have questions, you can also still raise in the chat and I will answer them. Yeah, hi. For your case, it is not currently supported, but our development team is still working on this case. You are welcome. Okay, that's all for today's meeting, and thank you all for attending. We have a survey. We have a survey, and please help provide your feedback in our online survey. Thank you. Have a nice day.